So welcome to the LandKit Climate Action Tools Workshop. There's two instructors, myself, Chris Landau, and Ben Summy, who's works with me at Landau and has done so for since before we even started writing LandKit, which is pretty awesome. And that was in 2020. And we, created plant kit and topo kit and paving kit, a lot of kits. And now we've recently added water kit to the mix. And these are essentially Grasshopper plugin. It's a Grasshopper plugin that allows you to do landscape operations a lot more easily within the Grasshopper environment, but it still requires quite a bit of Grasshopper, enough Grasshopper knowledge that you sort of have to know Grasshopper. A lot of our examples in the past have allowed people to kind of just go ahead and sort of get started with something, but weren't providing a super robust user interface. And we're now really focusing a lot on that. And we're not giving up at all on the folks who are using Grasshopper. In fact, by building these workflows, we provide even more capability for folks to modify and adjust those workflows for their firms, for their own practice, for their students, whatever the case may be. So, and it's just really amazing to have like an easy user interface and then like powerful tools underneath of that in order to kind of tackle these really hard, complicated design problems. And that's sort of what we're trying to do. We were really inspired in the fall by the climate action climate action plan that came out for the ASLA at their national conference. And, there was a nice clear vision and a directive and, momentum. And it's obviously a big, important topic, but this provided us some motivation because we said, look, this is ambitious. And the only way we're going to get there is when people are actually they're going to need more infrastructure, more tools to do these things and tackle these complicated problems. And so we immediately started thinking about the climate action tools. And we were already talking about carbon and water and this was really the push we needed. So, and we even did a communications piece about the climate action plan. Gina, who's our motion graphics person here at Landau, put it together a delightful animation that kind of talks about the key components of the plan and why it's important. And we did that for the ASLA. The other thing that came out during that conference was the biodiversity call to action. And, this is something we've already been talking about and thinking about with Plant Kit and how do you design more complex relationships between things, right plant in the right place, but also how do you begin to kind of like make connections between plants and all of those fun things. And so we thought that this was something that's obviously tied together with questions about carbon, questions about water, etc., and that all of this is sort of connected. So today we're going to talk about a biodiversity workflow that uses Plant Kit and talks about how do we take plants that are of varying needs and placing them in varying conditions kind of automatically based on rules. And then we're going to talk about how dynamically designing topography in 3D can allow you to see how water is going to flow on your site in real time and understanding different aspects of the flow that allow you to design that site better so that when you are collaborating with the civil engineer that collaboration can be more fluid, so to speak. And then finally, with water, the idea of using being able to calculate actual water volumes in case you are your site is using basins and things like that to really understand for yourself as a designer how much water is really going to be on the site, say, whenever there's a 100-year flood or 100-year storm, for example, and be able to think through that. And so that's a fairly sophisticated set of tools. And then finally, carbon, and how do we calculate carbon during our design process, and looking at material areas and what they cost from an embodied carbon standpoint, and or maybe what they can be sequestering, like if it's a vegetated surface or material, and then also looking at how trees play into that all at once, so that you're able to design your site, and while you're designing your site, you're getting a sense of these different aspects of the carbon part of your equation, or that part of your carbon equation is what I meant to say. That is not a totally comprehensive tool, but we'll talk about why and what it's good for. So looking at our agenda, we have 4 main modules. We're gonna look at, like I said, biodiversity, water, carbon sequestration. We're even going to do a little bit at the end about AI language models or large language models. But each of those first 3 pieces, and there's a break in between, but each of those first 3 are going to follow the general format of looking over some slides for 5 or 10 minutes, and then a demo, which is about 25 minutes or so, and then some Q&A if people have specific questions about that particular set of topics. So yeah, without further ado, let's get started. I'm going to turn it over to Ben, who's going to talk first about like some of the benefits of biodiversity, and then also, some of the challenges and some of the kind of answers we have for some of these challenges. So, thanks.
I'm muted.
Yes. You were muted, but yes. 2 other things. So Ben just shared the participant package, which we did not do in the last workshop. And so for folks who are familiar with LandKit and want to open things up, it might be okay. I would recommend for anybody who's like new to all of this to just simply understand what's happening. I think these workflows you'll find after the workshop are pretty easy to get into. You just have to have LandKit, and we have a pro key for the one. There's only one workflow that has pro components, and that's the second water workflow. As I said, we are recording this, so you'll be able to go back. You'll be able to open these things up, go back, look at how we're talking through some of these things. And yeah, Ben, am I forgetting any other housekeeping stuff before we go into biodiversity?
I don't think so, no. Okay. But if you think of anything, we can throw it into the mix as we're going. But yeah, as Chris mentioned, hello everyone, I'm Ben. We're going to talk a little bit first about biodiversity. I think a lot of us are probably very familiar with this term. It's been used a lot, thrown around a lot. We learn about and are exposed to it quite frequently in the practice of design and landscape architecture. But we're really trying to focus on this question of what can landscape architects or designers do for restoring ecosystems and protecting biodiversity and encouraging biodiversity in our projects, both big and small. So again, as Chris mentioned, this call from the ASLA to start thinking more like specifically about biodiversity and the connections and corridors and the ways that even on small sites, biodiversity can sort of enhance these larger connections and corridors to help create a more resilient ecosystem and even restore those degraded ecosystems. So even in simple ways, just by encouraging and planting and thinking about biodiversity in our small projects or big projects, we're starting to do that already. But we're really trying to think beyond this idea of, biophilia, designing with, nature in mind, but trying to really recreate and trying to build and restore these systems that are either being destroyed or can be difficult to create as well. And we know a lot about what these systems are capable of doing, whether that's sort of creating resilience and stability with an ever-changing climate. Those types of issues become very important, but also some of these ecosystem services that we as humans benefit from as well, and they become sort of feedback loops where we are using them and they need to sustain themselves as well. So these ideas of resilience and adaptability of the ecosystem become extremely important as we're taking action and making effect on the environment, and then having a system that can sort of be resilient to those effects, and even the larger moves in the climate is quite important. I think we're all pretty aware of. And then there's this bigger question about aesthetics and an aesthetically pleasing landscape or environment, and what does that constitute? What does that look like? And I think that reframing our picture of a biodiverse environment being something that's beautiful even to clients, and trying to sort of translate that, and showing that sort of image that we see from people like Pete Udolph, who are able to create these very biodiverse and beautiful landscapes in a lot of different places, whether it's the High Line or the Vitra Design Museum like this. So, but then it becomes a bigger question about how you have that knowledge and expertise in order to be able to do that. Like, that's a very challenging thing to do. There's a reason why he's one of the few people that are capable of achieving these types of designs. So there's knowledge constraints, there's educational constraints, there's the complexity of the amount of species that you're dealing with. And again, all of these challenges that we're talking about are the things that we're thinking about as we're developing tools and tricks and utilizing some of the data that's available in order to make it easier and more accessible to people like us, like the average designer who maybe doesn't have a PhD in horticulture and planting design. So, there's a lot of options and a lot of data sources out there, whether it's our own internal firms having plant databases that we use for our designs, or these larger databases like what the FHA has developed, the Eco-Regional Vegetation Application, which sort of tries to bring together all the different species that are native to the United States and create a more comprehensive list. But even so, you can tell that they're missing pieces of these traits that they're collecting, where maybe some of the plants don't have all the information placed in. So there might be a little bit of need on our part to fill in some of these important characteristics of plants in order to utilize them in sort of a data-driven design. So that's where we start to frame our picture always around this idea of parametric design and why do we use it. And we really see parametric design as a process, not a result. And so the idea of building and creating something that utilizes databases, that utilizes a lot of different environmental conditions on a site within the modeling software to create a tool set that can use these rules and characteristics of plants and site environmental and design decisions or conditions in order to place the plants on the site for you using a series of parameters that we have available to us. So we're really focusing on this rules-driven design on our site with plants. And here's a couple examples of what that's going to look like. And again, you'll see this once we get into the demo as well. But this was a much more comprehensive approach where we were taking in a lot of different environmental factors. We were taking in a lot of different native available species and implementing a lot of different design decisions into this site with these sort of 4 little islands here in the middle of an intersection that are showcasing areas where plants are dealing with multiple layers of characteristics, whether that's flower color decisions or salt tolerance decisions or sunshade analysis placements. And all of these plants are being placed based on all of these factors simultaneously layered on top of each other with a little bit of geometry input from our part. So the process is quite exciting to use and fun to use. And here's a little example of the plants on this small little example site that we created that are simply being placed by their sunshade and solar exposure preferences, where you have 3 different sun, shade, and part shade examples here in this coloration on the left. And you're really seeing that the plants are shifting into place based on their preferences for that one characteristic. And then it kind of builds off of that into this idea of implementation and visualization. Visualization is an incredibly important part of our practices these days, being able to see what you're going to get. So having the outputs in order to be able to quickly transfer these into a rendering software to actually visualize a very complex system quickly and efficiently, such as this one, where we used PlantKit in order to create these like biodiverse meadow spaces and different color palettes. So handling that complexity inside of a parametric model is much easier. We don't have to think about all these different characteristics of plants and different environmental factors. The computer can kind of process those for us. But thinking about the outputs to a visualization and even documentation, where we're continually developing these tools to make it easier for construction documentation and maintenance and planning too. So all of that kind of comes under the umbrella too as well of thinking about scalability and creating a set of tools that can work at the largest scales and the smallest scales simultaneously, depending on your needs. So let's just jump into the demo and start looking at it. Like Chris mentioned, we're also going to be looking a little bit at the workflows that we've been developing. So we're going to kind of focus a little bit on that right at the beginning. But just to kind of get things started, you'll see that we've created a site here. It's a pretty simple site. It just has some few trees that we have manually created in order to cast shadow on the site and create a sunshade set of conditions along with these buildings. We have these 5 different planting areas and a little plaza in the middle. So you're kind of seeing that visualization already of these spheres that are representative of the height and the radius of plants, and they're being placed based currently only on their sun exposure preferences. But it's kind of a fun little thing. I'll just hit randomize here right at the beginning where it will reprocess the script, and you can see a whole new set of plants reappear on the site and be replaced on the site. So it's pretty quick and efficient just to kind of see iterations right off the bat by using the randomize button up here. But sort of once you jump right into this workflow, you'll see that in every workflow that we're developing, we're giving a sort of a set of instructions that kind of guide you through the different tabs and the different layers that you're dealing with in Rhino up here. We do have a series of layers that you have to kind of pay attention to, but the nice part is that right when I open this, the Grasshopper is already minimized here in the left-hand corner. You can still access it, but it automatically minimizes for you, and you don't need to be in the Grasshopper in order to place new geometry in these layers, shift things around. You can do everything within the Rhino space and this workflow space. If you're savvy in Grasshopper, you may recognize this as Human UI. We again, shout out to the Human UI developers for making a very nice set of tools that make it easy to create these types of workflows. So we'll jump into what's going on here in this workflow now and kind of talk through and walk through what's happening here. So the first tab you'll notice here is the Plants tab, and you'll see that we have a few things here that sort of help guide you through what you're doing with your plants. The first thing to note is the plant data, or the CSV file that feeds in your plant database. If you click that, you can navigate to your folder that has your plant database in CSV format, import that, and it will automatically start drawing from that database. Once we get into the constraints portion, I'll open up that database and kind of show the relationship between how that's working with the plants. But for now, we'll kind of go through what this tab does, since it's a little bit more streamlined and straightforward, and then jump into the mix of the data a little bit here in a little bit. But once your database comes in, this database right here is downloaded directly from that eco-regional revegetation application website. And this database has almost 6,000 plants in it with varying levels of amounts of characteristics that are outlined. But what we have here is this allows us to specify how many species we want to pull from that database. Currently, we're only pulling in about 50 species, and then it's taking those 50 species, using their characteristics and placing them on the site. We can increase that or decrease that. The most important thing to remember as I sort of change this value to see the changes that's taking place is that you'll notice that our plant schedule here is not showing 50 species. The reason for that is that not all of our plants are going to have the characteristics that fit on our site. So if a plant can't find a condition that it likes, it just won't be placed. And then some plants, like in this one, we're pulling in 20 species, but we're only getting about 6 placed on our site. There'll be plants that like certain conditions, and they'll be placed all throughout the site. So this is a nice way of both kind of recreating that randomize that I showed you right at the beginning, but also kind of controlling, okay, if I'm using a lot of different layers of site conditions to deal with, maybe I should increase the number of species I'm dealing with so that I have more options to choose from. And if you're kind of getting into more custom plant kit type scripts and building workflows within the Grasshopper space, there's a lot more you can kind of play with this. But this makes it really easy to kind of visualize and create iterations to think about and start to develop ideas about your planting schemes and ideas. And then again, because the databases that we're working with specifically here with the ERA are based around the United States species, we have a drop down here for choosing your state that you're working in order to get native species, which is nice. And then the database also has specifications for types of plants. So if I just want sort of herbaceous perennials, maybe I want to include grasses in there as well. So I'll just check the grasses and it will reprocess and include plants that have that type of categorization. So it's a nice, easy way to sort of filter out and filter in the types of plants and different types of species you're working with. You'll see occasionally we'll get a gigantic radius of a species here that either is lacking some sort of radius indication or might just be a very large plant. But usually in this case, it's lacking some sort of data specifying its radius, and it kind of draws in a standard value, which Chris can probably speak to here a little bit more.
It's probably in inches, and it should be in feet.
There you go.
Yeah,
Yeah.
For that particular plant anyways.
Yeah. So, pretty straightforward, pretty simple. Again, if you're Grasshopper savvy, you can start to see a lot more ways that you can manipulate the way that your data is coming in. But this is like a very, again, quick and easy way of doing iterations and developing ideas about how to place your plants and sort of creating schemes to work with. So let's jump over into the constraints real quick, and I'll talk about a few of these and kind of jump into the database a little bit more too when I talk about the different types of constraints. So right off the bat, you'll see the first thing that we have here is a site size. The reason for this is that the way that the environment that we're creating is processing. So when we do sun exposure, it's basically laying out a grid of points and then analyzing each of those points on that grid in order to create an average value of how much sun, shade, or part shade each location on your site is getting throughout the year. So if you have a site that's very large, you don't want too many points that's going to increase the processing time of your site. So we've created this set of parameters to allow you to adjust that. If you're working on a very small site, you can work with the small site size, and it will increase the density of environmental points it's analyzing to give your plants a better chance of finding those locations on your site that are more specified. So this is a pretty small site, so I'll just decrease it down. And we have a couple of examples here for those who live outside the US. You can translate soccer to football if you'd like, just to make it a little bit easier on the mind. But right down here, we have, again, very similar to the plants checklist. We have this checklist that shows some very basic, straightforward site plant constraints that we can develop. So I'll kind of talk through the flower color really quick too, because that's kind of a fun one. So the sun exposure is currently being analyzed on the site using Ladybug. Again, shout out to a developer within Grasshopper who developed Ladybug. It's an amazing set of environmental analysis tools and has made it very easy for us to incorporate sun shade analysis into our workflows and to plant kit as well. So, once you check this, it's important too, like when you select a parameter, to go down and look at the analysis info and parameters tabs here, which give you a little bit of information about where to put your geometry, what does this analysis layer do, and also depending on the analysis layer might give you some input parameters in order to decide how is this parameter or how is this constraint affecting your plants. So like for sun exposure, we have a lot of these inputs to allow you to change the location of your site and your starting and ending planting months to increase the fidelity of that sun exposure analysis that you're doing. So right now we're currently in Philadelphia, and we're doing a March to November planting season. And that's sort of reflecting here on the site. If you look closely enough, you can kind of see where maybe some plants are a little bit more shaded down here on this southern part of the site. You can maybe tell that there's no purple plants in this heavily shaded area. But if we turn on the flower color, If you look closely on the site, and I'll select these two, you'll see we have a layer called flower color with some different colors outlined. But if you look closely on our site too, you'll see these yellow circles kind of sporadically placed throughout the site. These are our geometry that we placed on our site that are indicating which locations we want plants that have a flower color of yellow. And so you'll notice that as soon as we turn it on, within these circles, it's mostly just yellow plants, yellow flowering color plants. Now it's important to remember too, it's also using the sun exposure constraint as well. So it has to find a plant that likes the solar conditions in that location, as well as being flower color of yellow. You'll also notice that there are a few orange plants in here and maybe some off yellow or some kind of leaning towards the oranges and reds. If we go down to our analysis and info parameters, you'll see that we have a slider for sensitivity. And if I hold my cursor over it, you'll see that it's telling you a little bit of information about what this is doing. Because of the way the database works, and I'm going to open that up here in a minute and kind of show you and walk you through that a little bit. There's a lot of different shades of yellow, and a lot of different plants have different shades of yellow or subtlety orange yellows. And we want to make sure that we're capturing those range of colors that we want within these different zones. So if I simply type in the color yellow and provide an RGB value, if that RGB value is not matched perfectly, it won't include those colors. But with the sensitivity control, we can increase that to give us a buffer of color range. So that allows us to include maybe yellow oranges. If I decrease this a little bit, it might exclude some of these more orange color flowering color plants from our zones. And the same thing here with this blue zone. So if I select this circle here, let's just select the blue zone. I have this blue flower and color zone, and you'll see that there's a lot of purples in there. Purple is fairly close to blue, and because we have a sensitivity range of 125, so it's kind of reaching beyond that RGB value into nearby color schemes, we're getting a little bit of purple in that zone as well. So how does that look? How does that translate? So I'm going to open up this ERA database and look at it with you all really quick to kind of show you before I select, before I turn on the soil moisture layer and talk about that as well. You can kind of see what's going on. So this is the opening of the ERA database. It's a CSV file. It will work in any CSV reading software that you have. And you can see that we have a lot of different categorizations here, a lot of different plants. There's a lot of information in here that that you can use in order to place your plants, whether that's related to the height of the plant, the flowering month. You can see we have flower color, we have soil moisture and sun exposure. This is where the sun exposure is getting drawn in. And part of the reason why you're not really able to identify very easily just through the visualization of that's the plants on the site, whether or not a plant prefers sun, shade, or part shade, is because a lot of these plants actually work within all three conditions. So even if you have sun, part shade, shade, the software and plant kit will actually read those three conditions and utilize all three for that plant's preferences and characteristics. So you can use a lot of that. Same thing with flower color. You can include a couple of different colors, and it will actually incorporate those plants into the zones if it flowers those colors. So you have a lot of flexibility in choosing those conditions. And another one that I'm going to be showing too is soil moisture preferences for these plants. And some of these plants like multiple different soil conditions. So when I turn that on, we have a location on our site that prefers dry, and that's these two zones that you see here. And then over the entire site, we are using the soil moisture of moist. So we have a moist condition and we have dry conditions. You'll see that these are overlapping. Another fun thing about the algorithm that processes these characteristics and conditions is that if you have a smaller zone within a larger zone, the smaller zone will take precedent over the larger zone. So the plants within these smaller zones here that are in the dry soil condition, those will only find dry conditions. They will not find dry and moist conditions for those plants. So if I turn this on now, you might start to see a little bit of variation in the way that the plants are being placed, which is kind of fun. And again, now we're including sun exposure, flower color, and soil moisture. So now with 3 different layers stacked on top of each other, you'll see that there are fewer plants placed on the site becoming increasingly more difficult to identify locations for these plants for the algorithm. But there are some plants being placed. Did you have a comment, Chris?
Yeah, so I wanted to, I think this is a pretty good juncture to mention that, you know, the way there's a few fill algorithms for PlantKit, and the one we're using is the free version, which basically says place a bunch of plants, and if they don't fit there, just remove them, right? And it's more random, it's more organic, it's more throwing stuff at the wall, right? We do have a pro component that does a pattern fill where you can put in any pattern of points, whether it's a grid or a randomized set of points or whatever, and it will try to more persistently fill each point. But this here is one thing you'll notice is that it's not quite necessarily, you know, you kind of get a less dense fill, but then Ben can adjust that with the initial plant density. So he can double the density and then it sort of fills in a little bit better. If you're, you know, this is great for concept design, right? Where you can kind of push and pull and say, okay, I need a little bit more density and I'm going to add more rules, but then that's going to require a little bit more ammunition. The other thing that adds to this, and this tells us is how important biodiversity is, right? As you add more plants, more types to fit into these niches, the more likely you're not going to run into areas that are more sparse, right? But it also does show how constraining plant placement can be, right? Like once we say, hey, we want these aesthetic values, we want these performative values, then suddenly we realize like you add a few different rules and suddenly you're really up against a wall with where you can put certain things. But it also helps you identify like, hey, I really need to find some good blue purple plants that fit into that zone, right? And for example, right, it helps you identify where the gaps are as well. So this is a very exploratory process, and this you know, script is not meant for documentation. This is more for like learning and understanding and exploring. And you know, we are working on workflows that get you closer to documentation level type stuff where it's like, okay, it's in a grid and that's something a contractor likes better, et cetera, et cetera. Oh, there's one other thing I was going to say. It'll come to me.
Feel free to interject again.
Oh yeah, well, the one thing is that these parameters that we're providing, sun exposure, flower color, soil moisture, those are just some examples of things that we're pulling out of the database. If somebody wants to modify this workflow for their team or for their students, et cetera, they can go in and actually add in these other components if they want to. You know, it requires Grasshopper knowledge at that point, but the tools and the flexibility is there to set those things up, which is really exciting to us.
And another note about sort of adding your own information to databases and dealing with different sort of characteristics that you want is that you don't have to follow, you know, exactly the different characteristics that are in here. You can specify your own characteristics in any way, shape, or form that you want. And it provides a lot of flexibility to the way that you use PlantKit. But in terms of like structure of how you set up your database, we're kind of using the ERA as a guide for how to lay out your information or format your information in order to be able to use it with PlantKit. So in terms of formatting, it's pretty useful to understand sort of what this database looks like and how it's laid out. But in terms of what the information that you're inputting into it and characteristics that you're working with, that is completely free form to whatever preferences that you want, which is pretty nice. It gives a lot of flexibility to the way that you're using it. And again, you know, as I was talking about the layering of characteristics, you're already seeing a condition here where those dry zones are showing different types of plants than you're seeing across the rest of the site. There's a lot of these little plants that prefer dry soil conditions as opposed to these moist soil conditions. So you're already seeing some of that layering of information and characteristics that are being involved here. So I'll go ahead and turn on the pollinator value just so we can kind of see a little adding that fourth layer. And we've done scripts and planting scripts and planting sites where we're dealing with 5 to 10 different characteristics at a time, and it can be kind of exciting to see that happening and working, which is pretty fun. Another toggle that we have here that I haven't showed yet. There you go. You can see we have one zone here that indicates high pollinator value, and you can see that the layering of constraints is actually making it quite challenging for this script to find a plant that works here. So doing something like increasing your plant density, or randomizing to include another set of plants, or perhaps even going back and including more number of species to give you more options would be a good step here in this part of the exploration. But we also have this toggle here for packing plants. And what this does is it kind of shifts the plants around in order to fill those empty gaps on your site. And it's usually pretty subtle. Sometimes it can be kind of hard to tell, but you can use these packing steps in order to sort of iterate through and continue shifting those plants. So if I was to up this to 20, hit enter, if you look closely, you'll see the plants kind of shift around into place to start to slide into their positions based on the radii, so that you're really getting them sort of filled into the space appropriately to how you might actually plant them. So let's jump over now into the outputs, and the outputs are pretty straightforward. Again, as an exploration tool, this is super handy to use to kind of like create some quick visualizations, perhaps. But the range of tools available for outputting these plants and using them for other visualizations in rendering softwares can get quite robust once you get a little bit more familiar with PlantKit. But for ease sake, we've set up a few different outputs here to make things easier. So baked plants is where, for those of you who are familiar with Grasshopper, that's how you get your plants from the Grasshopper into Rhino. And I'll click that here in a minute and show you kind of what that does. You have output types here. So if you want spheres or if you want circles to kind of show a representation of the individual plants as circles on your site for what you might use for a planting plan. And again, we're continually developing the tools for the outputs of these kits in order to make it easier for documentation as well. So there will continually be more to come on that as well in the future. Go ahead, Chris. You might be able to talk about
documentation and visualization.
Yeah.
So if you're, so if you do the spheres, those are we baking those? We're not baking those as blocks yet.
Not yet.
We do have example workflows, honestly, that have where you can bake out blocks and you can bring those. There are tools to bring all that stuff into Lumion really quickly and be able to kind of translate that stuff into Lumion plants. For example, like you could also apply these things to other software. It's just a matter of connecting replacing blocks or making sure you're using the right blocks to place for each plant.
Yeah. And then again, when you're kind of ready, like maybe you don't want it to be sitting in Grasshopper because you want to transfer it to something else, you click Bake Plants, and you'll notice that it conveniently creates a layer called Plants, and it conveniently creates a layer for each species that are on your site. So if I right click and select those species, it will select all those. And we can grab all of the species of one kind individually. So it's a nice categorization tool for you if you're trying to identify different plants on your site. A couple other things I want to note here: the override bake plants button. I believe we have this set up properly, but we'll do a little test here, and I'll click randomize and create a new scheme here of plants that are going to be output. And with the override bake button, the idea is that if you're creating an iteration of a planting plan that you want to override and you don't want to delete all of those plants manually, you could actually just turn on this override bake, click it, and in theory, it will delete, as you saw, all of the old plants and replace them with the new plants. It won't delete your layers here. That's a nice little thing that we that we'll probably try and develop something that kind of works with that to make it so it can kind of get rid of your layers too. But you can see that it's very convenient. I don't have to go and delete that geometry. It just recreates it for me and removes it. But let's say you like the scheme that you have in Grasshopper and you want to be able to revisit it at a later time. There's a couple options here for you to be able to do that. You have a save settings option. So if I click that, you can see up here, it's prompting me to enter a name of this scheme. and I can do option 1 and hit enter. And what it's done is it's under here under the drop-down load option, it's allowed me to go back and actually revisit that option. It's saving the parameters that I have selected, and it's embedding them into this load option so that if I want to see it again, I can just click that option and revisit it. Yeah, Chris?
One thing to note is not yet, it's not saving the actual palette that you generated, which that's something we want to make happen, but the amount of effort to get all these workflows together, we just, there's more refinements to make, and that's definitely something we want to do.
But like in terms of the types of plants that you've chosen, the types of constraints that you're dealing with, and the different densities and packing steps, and all of these different selections that you've made to create this sort of set of plants that you're dealing with in a certain way is being saved into this load option. So if you want to go back through and see a scheme that's removing one of these options and see it in comparison to your old option, this allows you to do that pretty easily. And then there's these other set of quick saves, which are kind of nice, where let's say you just need to close out your program, but you want to keep those options available to you when you reopen it. You can just hit save current settings. And then when you open back up your script, you could hit load last quick save, and it will just open up that last set of parameters and constraints and information that you've inserted into your workflow here. So it's a pretty handy way of like dealing with that. Most, if not all of our workflows will have some form of saving like this to make it a little bit easier on you. The last thing I want to mention here is this toggle button at the top, which doesn't seems a bit inconspicuous, but it's actually a way to toggle off the entire script. So if I click that, it turns off everything in the Grasshopper and just puts it all on pause. And what that allows you to do is if you want to shift around a bunch of geometry, if you want to draw in some new geometry, but you don't want to update automatically every single time you insert something in, this is a great way to just put everything on pause, make all of your changes. Maybe I want to shift around a few trees and change a few things on my site, and then I can toggle that back on and it will just replay the script for you. So with that being said, I think we're at a good point to start transitioning either into the next module, or if people have any questions related to this specific part. Again, we'll have time at the very end of the workshop for questions. So if you have kind of like big, broad ideas that you want to go into more discussion about, maybe save those for the very end. But if it's more related directly to this, then yeah, go for it. But if not, I won't leave everyone hanging, and I will hit stop share and pass it back off to Chris.
Yeah, thanks, Ben. That was really good. So let me open our presentation here. Oops. Ben went through his. Okay, let's talk about water. Water is, water's a very important part of the whole climate question. We have to think about both how water can fuel plants, but also how it can we can reduce the amount of water going in storm systems to reduce the amount of cleaning costs, the carbon costs of cleaning water, and also thinking about storm events and how much water can our sites hold from a climate resiliency standpoint, and just all the good old green infrastructure stuff. So it's the reuse, recycle, reduce, all of that, but also the big thing is calculate. Like, how do we calculate water? And that's what we're going to look at. So thinking about like hydrological conditions and we can understand that there are benefits to understanding water flow on our site, and assessing how it does so that we can get our leads and our sites certifications for local, state regulations, etc. And then as I said, the climate impact, and then also potential water reuse, and the better we can understand the water on the site and how it can capture it, etc., the more we can do, really. And just a main thing I want to mention here is that typically we are working with some sort of civil engineer on projects like this, and we're not saying that our tools replace the civil engineer. We are saying that they may help the landscape designer to understand those aspects of design a little better within their given project so that they can collaborate better with the civil engineer. So the challenges are, one of the big challenges is often, communicating with the civil engineer and waiting for the civil engineer to do all of that work before we know whether our design works in some sense. So being able to balance your water use, look for rain event complexities, do some code compliance planning within the design, maybe even if you understand enough about your locale and your site in that way. And then, as always, making the sell, educating clients, letting them know. And this goes for not just the water stuff, but also for the biodiversity stuff and the carbon stuff, where we can actually show them, visually how things impact in a way. It's very important. So aside from like the obvious things we want to avoid with water on a site, like insane erosion, and just understanding that water is going to flow to this location and that, there's a certain soil here that might be an issue. We want to start thinking about how can the site, more and more, how can the site kind of collaborate with water and using plants and topography to kind of hold water in temporary ways and infiltrate it, or even in this case, I think this is probably a longer term wetland or a vernal pool. So there are two really big strategies I mentioned earlier. The first is lengthening the path of water. So, increasing contact time, reducing velocities, enhancing the kind of overall distribution of water on a site, and extending the percolation time so that water can really get into the ground and into the plant's roots, and we can sort of use water as as fuel for our climate initiatives that we're trying to achieve. A really good example of this is the stormwater rules that have been implemented in New Jersey. This is just also something we know about. So we created this graphic as an illustration of the new laws in New Jersey for stormwater. You now not only have to have basins to capture some stormwater so that it's not all going into the storm drains, but new developments also need to have vegetated basins. And so some of the recommendations ENLP has made, and ENLP is, we'll mention them again, they've been helping us with understanding water a lot better. They're a New Jersey, Philadelphia firm, engineering /landscape, sorry. And they were writing the kind of the manual for this and the recommendations and doing sort of a PR campaign for this new set of laws. And it's really about extending water, extending the surface areas and placing more of these basins rather than one big basin. Typically it would be a big basin right here over this whole area rather than kind of distributing it across the site and making it part of an amenity and part of a triple bottom line equation. And this can happen in cities too, obviously, right? We want to kind of, think about bio solutions within the city as well. Some really nice examples of this all across the landscape architecture industry. I just saw a really cool animation just yesterday from CMG, which looks really neat. So the hard part is making it all happen on your site and coordinating these things. And this is an especially hard one because it has, like actual, ponds and things. And this is a little advanced. But, how do we start going from the concept and start saying, like, how does the water flow across the site? And then depending on where water goes, that defines catchments. And we can understand that sort of these zones of water capture within, these little watersheds within our site. And then how much volume are we getting for any given area based on the kinds of soils, the ground covers, and the last one, soils, and then like the conditions of the soils. And the rain events, obviously, is another thing that needs to be taken into account. The other big strategy is water volumes, right? So that I've already started chatting about here. Green infrastructure is, it requires understanding these volumes. Rainwater harvesting requires understanding these runoff values. And in many cases too, understanding what kind of vegetation selection you might use, and like where is water going to go? Where is it going to fill up and be the moist, moist soils, etc. So all that's very fuzzy and fun, but let's look at a really technical example. And this is what our infiltration volumes example is going to look at. The TR55, it's a technical release from the USDA that explains how to calculate stormwater on your site. So you start by taking a catchment, which we can see here, we have a catchment, and then you break that up into all these sub zones or sub areas, as they're calling them here. And each sub area is broken up based on all of those varying conditions, because you may have overlaps between the soil type and the ground cover, and you might, instead of having two kind of sub areas, now you've like got 4 different potential areas, right, within one catchment. So from all those different types of sub areas, there's a way of determining the amount of water using a curve. And there are different curves for each one, and that's called, and then we decide on those based on a curve number, okay? And there's charts to decide which curve number that you have for each of these sub areas. So you have your cover type, your condition. So this is the sort of the condition of that cover of that ground. Most of the time, according to ENLP, like if you're constructing a site, constructed landscapes are usually a good soil, because you're trying to replace soils and things and update. But the third piece is the hydrologic soil group, which is A, B, C, or D, and that is kind of like whether it's sandier or more clay. So the higher numbers are less permeable. So you imagine a clay, even though it can hold water after it kind of gets wet for a while, it can hold water for a really long time. Clay is not a great way to kind of permeate. And so A soils are sandier and D soils are more clay. And then this is a great, just a really beautiful map of hydrologic soils across the whole world. And there's GIS data available, so you can figure out where your soils are. We're going to include a link to that eventually whenever we have the package with the video and all of the contents. So the typical process for this, and I'll just go through this quickly, is filling out a sheet like this. And you'd have a sheet like this for every single one of the catchments on your site. And if you've got a site that has 20 catchments, and then you've got, and on this one, there's 7 subzones, for example, just this in this little example. So 7 times 20 is like 140, different lines that you're filling out. You've got the hydraulic soil group, and they also have the soil type here. And then the cover and the condition. And then based on that, you pick your CN number and you get your number of acres. That helps you get an average CN number for your whole catchment. Okay. You're typically manually doing all of that. You're calculating areas, you're drawing the areas in CAD, and it's a very intensive process. The last piece, once you know how much water is, once you know these values, there's an equation to calculate how much runoff you're going to get, how much volume you're going to get based on a storm event. And so we have a link here to the NOAA website that will show you what kind of estimated precipitation values in inches you get for any one of these storm events. Typically, you're going to look at a 24-hour storm event, and you may be designing your site for a 100-year storm, or maybe more ambitiously for a 200-year storm. It's all going to depend on you, but probably being able to capture more water is better. So why parametric design? Well, the first reason is completely obvious, which is calculating all this stuff would be way faster if we had some sort of calculator, some sort of thing to kind of gather all of the information together, so it's much easier to do, and we've done that. We also, be able to visualize just the movement, like we're going to talk about in this first example, and then as we said, being able to communicate with civil engineers to show your clients, to explain how these things work to your students, and just understand these systems. And then all of the other fun things with water management and regulations and all of that. So without further ado, I'm gonna kick it back over to Ben he's gonna talk about the manipulation of topography and looking at how water flows and kind of understanding those relationships in the workflow that we have. And then we're going to expand on that workflow and talk about volumes.
Awesome. Thanks, Chris. Okay, so again, you're going to see a very similar layout with the workflow here for this sort of topo water example. You'll see we have some very basic information here just already laid out on the site. Sort of a boundary where our topography will take place and be constructed, and then a few of these path center lines that are sort of defining where we're creating our topography. And then you're seeing sort of a visualization of those paths at elevation. So how are these paths being generated? Again, we're working within TopoKit here, as Chris mentioned. We're actually using that within our Grasshopper script down here that's minimized. So if you have some familiarity with TopoKit, you'll recognize a few of these different layers here that are involved in reading and developing a TopoKit topography. And basically what we're doing here is we're providing center lines that represent the center line of a path that we're creating. And you'll see that those actually fall perfectly within line where those visualizations are taking place. And then at the beginning of the center line, we have these points that are elevated in space in 3D to the location where those paths will begin. So we have a center line here, this big squiggly blue line, and then we have this beginning point here, and you'll see that the path begins at that location and then just begins sloping up and swerving around according to that line all the way to its terminus. And then you'll see we also have another path being generated over here that's starting sort of at the end of this other path, this first path. And we've elevated the point to sort of meet that path in space where it intersects. So there's a little bit of fun play here with sort of getting those to match. The way that we're actually developing the elevation from that starting point is by using a slope parameter. So we're simply inputting a single slope value for each of these different paths. And in some cases, we're dealing with a swale slope. So these blue lines represent what we're going to use to create swales. And then this yellowish orange line is what we're using to represent a path, an actual path. So the center path here is at a width of 6 feet, and it's sloping at 5% up from this bottom point. And then these swales have a slope of 3.6 that they're sloping up. So a little bit different. And again, the reason why they're kind of reaching the same height is that they're longer. So the length of your curve matters just as much as the slope of your curve in order to develop a topography in a way that you're trying to achieve. So if you have a greater slope and a shorter curve, it's going to look different than a longer curve with a shorter slope. So that's how we're sort of creating these paths, and you'll see how those come together. But we also want to showcase the basins here that we're using to create in and around these paths. So we've developed these basins and we've elevated, again, them to their place in three-dimensional space, which if you're familiar with using a little bit of TopoKit, you'll know that we use a lot of very simple and basic geometry to construct our topography. And we're using these curves here in order to create the edges of our basins in 3D space. So once you see the visualization of this taking place, you'll see that all the basins that we're creating are actually beginning, and the topography is sort of generating up to the edges of these basins that we've drawn in and elevated in 3D space. And then we've also provided some parameters here in this first topo tab that gives us the ability to increase and decrease the depth of our basins, as well as the slopes of the insides of our basin. So both of these parameters will affect the inside of the basin to adjust how steep the side of the slopes are and how deep that basin will actually go. And then up here, you'll see that we also have a few different parameters that allow us to control the detail of our topography that we're creating. This topo detail actually allows you to adjust the way in which the points are being divided up in order to generate the topography. And again, if you're a little bit more familiar with TopoKit, you'll kind of know this is the minimum and maximum division. But the basic understanding is that the higher this value is, the fewer number of points that are being generated on your site. So this is an important parameter to pay attention to. If you're dealing with a really large site, you want that number to be bigger. And if you're dealing with a really small site, you want that number to be smaller. So we're dealing with like sort of a medium small size site here, and we just have this value at 2, which is pretty good. So let's jump into the analysis and let's start to sort of visualize what's happening here. I'm going to go to, well, you'll see that here in a little bit, but so I'll turn the contours on and show it, and you'll see that we're actually generating the topography here. You'll see that our paths are actually showing sort of the cut across to create a nice smooth path being generated down. We have these swales being generated, and you can see the contour lines inside of the basins. So in this basin, you can see this orange contour line indicating that the inside of it has dropped down 1 foot. We can increase and decrease this interval in order to see a little bit more detail on our site. So this kind of gives us a little bit of an easier to see the topography visualization with a 0.1 foot interval. So I'll keep this on for now to make it a little bit easier to see what's going on.
Hey, Ben.
Yes.
Just don't forget to mention break lines.
Break lines. Yes, I just saw it. Thank you for bringing that up.
Yeah.
So you can see here that even though we have this path and this swale generating here, and we have these basins that are outlining exactly where the basins are going to be in three-dimensional space, you'll kind of see that there's this like line that's being generated here, creating a flatter zone. I can even draw that in. You can kind of see it kind of being drawn here like that. So if I turn on my break lines, and again, for those of you who are familiar with TopoKit, this will be pretty obvious to you, but we are using simple curves connected between these basins in order to generate and sculpt the topography in very particular ways. So for instance, here, we didn't want this topography to just slope from this swale down to the path. And if I take this curve and I drop it down like that, you'll see that the topography will change and it will now start sloping down towards that path. And it's a little bit less flat here. That will affect the way that our water flow is happening on the site. So we're using these break lines in order to sculpt around these basins and paths in order to generate a type of condition that will work with the water flow that we're trying to create. And I'll kind of show that. I'll pull up the slope analysis layer here, because that kind of makes it a little bit easier to see what's happening. So you're seeing this visualization of all of our slopes on our site. This is kind of handy because if I want to adjust my basin slope to a little bit less steep, you'll see that they all change in unison together, and I can increase that back up to 0.5 and get them a little bit steeper. So we'll come over here and we'll visualize what the water flow looks like. So I click the water flow on, and you'll see almost instantly the water flow appearing. I'll switch from slope to something else so it's a little bit easier to see. A little bit easier to see maybe what's happening here, and I'll increase this interval up. So you can see that the water is flowing in a lot of different ways. We have everything's kind of following these paths and swales and coming down, but you can see even in certain places we've adjust the topography using these break lines in order to get the water to fall off of these swales and into these basins at different locations. So it's a handy way of seeing kind of live updates to what's happening there. And again, like I showed you before with this break line, if I take that break line and shift it down to kind of open up that swale to the other parts of the topography, it will adjust that topography and we'll start to see water flow happening across that swale into the path. And you'll also notice that we have another break line right here where this water is flowing to keep the water from hitting our path. So there's a lot of different ways that you can use this visualization to quickly see how the water is automatically moving on your site and adjusting according to the topographic changes that you're making. I'll talk about catchments here in a minute, but I'll talk about these other parameters that show up when you have your flow lines on. And that is the cell size and the environment cell size. So the flow cell size is a way of adjusting how many flow lines are being generated on your site. If I take that and increase that to 20, you'll notice that there's a lot fewer lines on our site. That kind of is similar to the way that we were talking about the topo detail. This is saying the cell size, the grid of points that are being laid out on your site where each of these flow lines will have a beginning point is a distance of 20 feet apart. So if I decrease that down to 5, the distance between that grid of points there.
I think Ben's going to have to refresh. I'm going to just let him know. You guys there?
Yeah, I'm back.
Yeah. Okay. Okay. There he is.
Had a wonderful hiccup. Sorry about that.
Your computer needed a tiny break.
Yeah, it's mad at me. I've been doing too much on it today, as we all are probably familiar with. Is it sharing? Are you all seeing everything yet? I'll stop and reshare.
Not yet. I feel like, Ben, I would turn the contours to 1 foot. Like, it may be something your computer can handle, but with Zoom combined, it might be a little like graphics intensive.
Yeah, I already changed those down and reshared. Yeah. So,
but the cool thing to note is that when you're building a mesh, you can go from a rough like 1 foot contour type plan and generating contours as an output and kind of move over to kind of like looking at micro grading pretty fluidly.
Yeah, which is nice. And again, we sometimes have this problem because Grasshopper tends to use a lot of similar processing and video tools that Zoom uses. So it's always a fun thing when you're showcasing to remember, keep things a little bit less processing heavy if you're showing Grasshopper over a Zoom, the old tooltip. So here is another environmental layer or analysis layer that I'm showing here. And Chris is going to get a little bit more in detail on this. And you're just seeing like a very simplified visualization of this. And I'll zoom out a little bit so it's easier to see. But we'll take a chance on it here, Chris, and see if we can get this to not crash. But it didn't crash last workshop, so hopefully it won't. There we go. So what you're seeing here is a representation of catchments. And what this is doing is it's analyzing the flow lines and where they terminate or cut off and stop flowing or start squiggling on themselves, which allows you to see the ways in which the different flow lines are connected or disconnected across your whole site. If you're familiar with watersheds, again, very similar to the way watersheds works, but on a much smaller scale. But we're kind of seeing a visualization of the different watersheds that are happening here across our site. One kind of fun thing that I think is a pretty fun thing to use when you're dealing with these different catchments and you're trying to like create a more comprehensive water management plan on your site is the inclusion of pipes. Oftentimes our basins are not standalone. They're usually connected by piping systems for overflow drains and things like that. So keeping that in mind, we've incorporated that into the mix. So if on my pipes layer, I place a polyline that connects one basin to another, and kind of hard to see these basins up close, but I've basically drawn a line that puts one point inside of one basin and one point inside the other. And you'll notice that it actually connects these two catchments together. And it starts to create a system that is connecting whatever is terminating in this basin is now eventually going to overflow and connect into this basin. And I can continue that even. I can connect this basin to, let's say, any of these basins that I want to. I could connect it down to this basin, and it will change the coloration of these catchments to adjust to how the pipe is connecting the system. You'll notice it didn't change it too much. There's a little bit of connection between those systems already. There's a slight color change, but it's kind of a handy way of sort of enhancing that visualization and analysis when you're dealing with your topographic changes. And again, we have some very similar outputs here. We have some flow line outputs in case you need to bring those into another software or use them for other purposes, and a baked topo as well. And like mentioned before, a lot of the same workflow saving and toggling settings as well. Did you have any other comments before you want to switch over, Chris, that we should bring up on this one?
Yeah, I just want to mention the pipes. The pipes are kind of like both. They could be thought of a little bit more literally, but also as something that is more of a way of annotating connectedness between catchments. So you could think of the pipe as like, maybe there would actually be a pipe there that's an overflow pipe that would then go into this other basin if it filled up. That's one way to think about and design your system. The other way is to sort of say, hey, like this is a way of connecting this one to this one, because we know that when this overflows, it's going to flow into this one, right?
Yeah.
And so it's just, we think it's better to start with discrete zones, pre-pipes, but the pipes provide another way of starting to say, okay, I'm going to connect these together because I need to understand this whole thing as one watershed, and that's going to simplify my reporting a little bit, et cetera. And I think it's also a matter of like consulting with the civil engineer that you're working with and understanding like how they're thinking of this system and how to kind of how to kind of achieve those goals together.
It kind of helps like when we see things on the site too, such as this condition here, where you see that there's a catchment and then another catchment, but this is one continuous swale. The grading has sort of made the water fall off into this basin over here, but we know if there's a massive enough rainfall, the amount of loads of water flowing through that swale means that not everything will flow off, and some of it will continue on. So being able to capture that using things like pipes is pretty helpful as well too.
Yeah, that's a really good point. That's an interesting thing about this particular example that we've provided is there's this dynamic tension between is it going to flow along the swale, or is it, how much do you want to put into the basin? And there's probably a few different design directions you could go with there. Let me share the other example here. And this is just building on the one we had. So this uses some pro components, and we've also added a few extra bells and whistles to this particular one. But a lot of this stuff is similar. You have the ability to change the topo detail to kind of extend the topo out if you need to. Adding contours, it's showing them, not showing them, showing the paths as a geometry. And then, all that stuff is exactly the same as the other one. But once we get into analysis, we have a few different ways we can visualize this. So this upslope area is it's strange on this example, but upslope area can sometimes show you sort of like how much area is contributing to a certain location. And it works sometimes to kind of understand some of those dynamics. There's the slope, as Ben was showing, which can be really helpful when you're designing topography. Slope is kind of important. And then there's a slope layer as well, which is kind of a little bit fuzzier and is not based on quite as much of a faceted analysis. I believe this one actually might be slightly faster too. And then there's elevation, which is good to see and understand. And flow intensity, that's kind of one that we don't have in the other example. So flow intensity, you can see, for example, here on the right, we have a lot of the water flowing and being decanted into these basins before we get too far down. So you can see a bit of intensity there, rather than along the basins. So if we were to, come over here and take this, I got to turn on the basins, take this basin and bring it down just enough. It's going to absorb some of the water that was flowing down, and that's gonna reduce the intensity of our flow downhill on the swale. So it's, we may also just, maybe our basins here aren't big enough. maybe we need bigger basins. So it shows you the system. That's the thing. Like it rather than sort of just kind of, it's visual, because we're visual people, and we can kind of design and think about these things all at once. So where we get into sort of the more technical thing is this, understanding CN numbers. And once you select CN, it's automatically going to preview the CN values. So the darker values represent a higher number, meaning that it's more impervious. So like our plaza up here, we determined as very sort of impervious. And then these basins are the lightest color. And so part of the way we arrive at the CN number, as I was mentioning in the earlier presentation, is so we can visualize some of these layers. We can visualize hydraulic soil group, HSG. So these are, the default is a hydraulic soil group of C, but then we have an analysis layer that has different groups. So we have a D group up here, and then we have A groups in the basins because we want the that's a more sandy soil. And then for, just to show you guys a variety of stuff, we have our oops, that's the basin, not the group. We have our B group sort of in these areas in the middle. So that's one layer of breaking up our site into pieces. The next layer is ground cover. It's thinking, sorry. The next layer is ground cover. So essentially like your site areas, right? How are you designing the site? Is it a meadow? Is it wooded? It's really thinking. I'm not sure what I did. There we go. Ground cover. So we've said, okay, this is the default is lawn. Just for demonstration, I don't have it broken into too many regions. That's a lot of lawn. I wouldn't recommend lawn for this kind of a landscape. But then the we're breaking this into zones for ground cover. So if I, for whatever reason, it's thinking every time I show a layer in this case. So, but basically, it's another layer. And over here on the right, you have every single sub area, right? With like, these are the catchments, B0, B10, B12, B4, B9, C10, all of those are the catchments. And we're seeing the average CN number from those that it's calculating. But the contributing sub areas are also listed here, and we have all the areas of all of those sub areas. We can export all of this data to to a C and to a CSV file, and it lists all of those things in groups, right? Similar to the way we would enter all that stuff for a for our sheets that a civil engineer would fill out. So you can at least, you can give that information to a civil engineer. They're like, well, how did you arrive at this? And you say, well, this is this is what the thing spit out at least, and then you've got some sort of conversation that you can have there. If we just kind of go down a step here to calculating volumes, we look at, we've got this value here, the P depth, which is the precipitation depth. And we can go and find that precipitation depth by clicking on a button that opens a web page from NOAA, and it's about sort of weather stuff that we saw from the slideshow. I can double click on Philadelphia, zoom in here. And I need to use the plus. There's not a scrolling zoom. And just say, okay, well, the site's over here. And then I look at my 24-hour rain events, and it's 7.64. So now I go back over here and I input 7.64.
Yeah, it's that. Did you have that on a different screen, or were you sharing a different screen? I don't know if anyone else didn't see it, but it didn't show up for some of us, I think.
I may not have. That's strange. Maybe it was because it was so quick. I think the zoom is like maybe just moving a little slower today. It's weird. No, I think it's probably just not sharing. Let me reshare the screen. Okay.
There it is.
There we go. So I had shown this before in the slide, but you essentially say, okay, I have a 24-hour rain event, and it's a 100-year storm, right? So it's going to be 7.6. And then I just enter that number here. I hit go, or I hit the button here next to it to make sure that it calculates, and it immediately updated this number here. So this is the amount of volume in a 100-year storm event over my whole site. Now, if I zoom in, it's also going to show me the volume for each catchment. So let's switch over to catchments here to see this a little bit more clearly. So I can see the catchment. Nope, that's the CN catchment. And also in this workflow, we've moved the option of catchments under the category of CN, just so you know. So I can see, okay, each area has kind of a high point and a low point and a volume for that area, right? So we can start to see, oh, I see why that doesn't get much volume, because we didn't, this whole thing is supposed to be flowing into here. Well, maybe that's because there's something up with the topography. So I'm going to grab that swale, scale it out a little bit so that it's dumping out here. Give it a sec. It'll join these two into one catchment, and it's going to change it changes the volume of the catchment, but it also changes the overall volume of our site. Because what we're doing is we're saying, well, it should be a subtle change, but because you're distributing the amount of water across area, but maybe it didn't change it. Sorry, that was a, yeah, not quite right. So some of these colors are a little subtle, like there's two different blues here. So one catchment goes down here, one goes down here, but you get the basic idea of that. I'm trying to think of any other aspects of this. Does anybody have any questions?
I don't know if you had a chance to show the static storage too as well, Chris, of the basin.
Oh yeah. Which
I think is a pretty handy visualization, and speaks to the dealing with large volumes of water on site.
Yes. Okay. So, so I just wanted to show you this too. So if I want to export the CN data, so if I go and I say select this, and I figured out the path, it goes here to this CN CSV. You say save, and it's going to replace that. And then if I go and open that, I just wanted to be able to show you guys what was happening on that CN file. So we're gonna, yes. So this is our hydraulic soil group, for each catchment, catchment B1, we've got hydraulic soil group A, meadow good. That gives us a CN of 30, square footage, acreage, CN value, or sorry, CN times acres. And then this is our average value. So this breaks down every single one of these things. So imagine doing all of that manually. Not fun at all. So the other thing that Ben just mentioned was that we know that we have about 40,000 cubic feet of water for a 100-year storm event. So now we can go to our another analysis layer, which is the static storage. And I would love to make these show at the same time so you can kind of see them together, but we just haven't set that up yet. But the static storage shows you, so using the basin curves, it says, okay, within this area, how much water can be stored within each of those, the topography that lies below that kind of that number. So what am I trying to say? That area. And we get a heads up display of, label for each of those volumes. And then we also get a total volume here of 57. So we have enough storage capacity for a 40-year storm event. We have a lot of basins, so we should, right? If we don't have enough storage yet, something's wrong. So yeah, so that's static storage. And what else? Flow cell size. So one thing I wanted to show you was, if I go to none, or actually, so CN, and then we show the grid flow, and we had that button on both workflows. So that you see the flow here. This is kind of a more organic flow flowing across a topo mesh, whereas we also have a visualize. The way we're calculating catchments is using more of a grid flow. And if I turn off my flow lines and all of these other things, oops, you can see that. I'm going to turn these off to paths, contours. You can see that we're using a more of a grid sort of raster-based flow in order to determine these catchments. But this is another nice visualization to understand where things are stopping and where they're coming from. There's a nice kind of aspect to this where you can see the longer the path is, the whiter, brighter it gets on this background of darker colors, and you begin to sort of just really see where these paths end up and understand the dynamics of at least why it thinks this is working this way, right? Yeah. Okay, so let's answer a few questions and take a 10-minute break. So maybe we spend 5 minutes to answer a few questions, and then we'll take a 10-minute break. How's everybody feeling? Are there any burning questions about the water stuff?
I guess from, not to get too into the weeds of it, but I guess would y'all recommend, because I see a lot of it is in kind of like top floor view, right? Like the actual analysis output. So when thinking of starting with the site, right? I mean, because I was kind of clicking around during the workshops about the layer. I mean, I know the LAN is a lot of layer management, right? So, or it's some of the scripts are kind of draw it first and then make sure that it's in the right layer. And then sometimes it's, if you want to edit like the pipes, for example, you make sure you draw it in the layer it's in. So would y'all recommend, if for existing geometries of projects or designs, to start, I guess, is it like a chicken and egg kind of problem, or is it like
no? I think there's a couple ways to look at it. So if you want to use, so we have for topo, we have like a layer that, I'm not sure, do we have it? You can add contours as a layer, but in Grasshopper, and this, we're going to get under the hood here a little bit. So this is the workflow. It's a lot more complicated when you add all this UI stuff. But if you know Grasshopper enough, you'll be able to see, hey, like I actually have this information for topography that I'm pulling together like a geo set for the topography. That is bringing in break lines from this layer as curves, or it's getting all the curves off of that layer. I can also bring in meshes. So I can bring in existing meshes that I had. I can also bring in spots, and you can also add in contour curves. So you could basically copy this and have a layer name. But the neat thing about that is that you could go in here and you could doctor this and say, hey, our firm always uses these layer names. We're going to doctor this so that it pulls those layers in automatically, right? And our philosophy is that everybody's using some sort of layer structure. It should be on this layer. This thing should be on that layer. This thing should be on that layer. And it's a way of not having an extra data layer of organizing. And obviously, this is a little different for BIM because BIM doesn't have layers, but it does have these kind of categories of things. And we're hoping to make some workflows that kind of accommodate, ingesting data from a different viewpoint in the kind of BIM environment, but we're just not quite there yet.
And Chris, this is rather quick question along those lines. I'm curious a bit if you can expand on sources of data for creating topography, right? A lot of times major grading is done by Civil, so there's Civil 3D, CAD, and there may be other sources. I'm not sure exactly what range of inputs you can accommodate to generate topography.
Well, the neat thing about Rhino is it's so versatile. Like you can bring in all kinds of different file formats. It does have some limitations with GIS, but we do find that if somebody generates a mesh in Civil and you can bring that mesh in, we can use. Hello.
I think it's just some background chatter.
Okay. We can bring in meshes, contours, spots, surfaces, whatever you have, pretty much we can bring in and use.
But a comment that we always
I'm not quite sure. Yeah.
Oh no, go ahead.
I wanted to just clarify with Radu, like is there a particular kind of information you're wondering about bringing in?
I'm still sort of thinking workflow, right? And
yeah, absolutely.
ownership of data and scope, right? And that's where we're very sensitive to that. Basically, in a BIM environment, that's obviously my main sort of environment. And I'm trying to understand the process from that perspective, right? Okay, yeah. So usually we get a topo surface in one way or another from Civil, and that can embrace many sort of formats, from published topography into BIM 360 platform to just essentially content from a CAD file. And I'm from that perspective, just kind of trying to see what's possible here, right? And I think you're saying this assimilates CAD very well, right? I mean, as a file format. And what other ways can we use?
So the neat thing about the way these meshes are all being generated is that, well, at least for if we look at the topo, right? This is a Delaunay mesh. And if you brought all of the same point data into Revit, it would mesh in a very similar way, right? Because it's not doing some crazy weird mesh manipulation after the fact. It's just using a Delaunay mesh. So, and we're just preparing all the points in such a way that make them work together. This is especially true with the wall stuff that we have, like having the mesh kind of dive through a wall without crazy sawtooth effects is something unique for our tools. But one of the things we found is if you're trying to generate an existing mesh from contours, there's a there's a big disconnect on how that mesh is going to come together. And we're often having to do a reverse thing where we draw break lines quickly. We might spend an hour or two just tracing out all of the, just going through. If this were the existing, we would just go through and we would go click, 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 and go through and build out all of the break lines for those different, ridges and valleys and edges, in order to make the topography mesh represented the way that it needs to be in a digital environment. See, when we look at contours like that, our brain connects those, right? Oh, that's a swale. I know, it's silly. Like, why would, and that's why we use contours, right? Because we can see it. But there's a huge problem with designing with contours and translating them into 3D. And I would recommend anybody who's using contours for existing when they could use a mesh, I would say try to use a mesh, especially when you're using this kind of design process where you can bring it in, even if you have to resample it or something along those lines, for your existing mesh. We have all kinds of workflows for existing and proposed meshes, but this is just a quick demo with only one layer of data. Like, we actually are often saying you can have your existing and then you can patch in proposed areas. So you might get your point data or your mesh data or your contours of the existing site from your civil, and then you can pull all of that into Rhino and put them on the right layer, or rename your layer input in Grasshopper, as we were talking about with Carlos. And then you would begin to make your manipulations, your design interventions within that existing site. And that's like a whole topo kit workshop that we actually gave yesterday to a company. But we do have that information about that on a few of our resources on our website, and also through Campus Plus. We have like a whole workshop that we did that you can access.
Thank you, Chris. I think
yeah.
Were we gonna have a 10-minute break?
Yeah, let's have a 10-minute break. No,
yeah.
Or let's have a 5-minute break in case anybody has already just stepped away. Awesome. Ben, you can take your break. Ben, I stepped away a little earlier, so okay. Go ahead and go for it. And I'll hang on in case anybody has some immediate questions relating to topography or water or even biodiversity. Like I'm just having trouble viewing. Does anybody see any immediate applications to projects they're working on? This would be kind of a quick question. Or do you I guess another question that I have is how valuable do people see this water stuff as? Are you convinced, or do you still feel like, well, no, we're just going to rely on the civil? Or that's kind of a big question I have. We do have a survey at the very end of the workshop that we're going to ask everybody to fill out if they can. But I'm also curious, just feedback wise, what people.
I can jump in here to say a little bit. I do use LandKit. I mean, maybe a little bit more frequent than others, I guess, in my workflow. But I feel like the way I use LandKit is always it's part of my process, not like the whole of my workflow. Like sometimes I found, like for example, I found the topo generation part of the LandKit is super handy, and especially when I want to modify something. But I might have like other things generated by other people or me in other way in other softwares. I just use LandKit, like not building everything from scratch, but like I have a mesh, I have some other things, but then I just put it together, and the LandKit because it can take in the break lines, it can take in all kinds of the geometry. It's a very good place for me to put everything together. That's one super handy thing I find Landkit to me. And another part I enjoy Landkit is like for some quick visualization. It's not like there are not people who or other software who can do the hydro analysis, who can do the topo visualization. For me, it's always like, but in Landkit, it's just one component. I can just put it like super fast for some faster visualization as a way to exhibit the thing. But on the downside, I do feel like when I really want to build something a little bit more rigorous, or process the topos or other information on really large territorial scale, I cannot do prefer using ArcGIS or other platform compared to Landkit, because 3D is always a little bit buggy, and not the Landkit, but the 3D in general. It's a little bit more buggy than the way, I'm not sure how ArcGIS is processing the thing, but it seems more easy for the large database processing.
Yeah.
That's my feeling.
Yeah, at a very large scale, you really have to have some knowledge and skill with Grasshopper in terms of like how to handle the data, because it can get a little sticky. I think we're very focused at a site scale, but we've been testing this at larger scales and have been optimizing things quite a bit. Even in the dot release that we have in the participant package, we're just constantly making new realizations about areas that we can speed things up. But yeah, no, thanks Yushin for sharing. I think one thing that reminds me of some stuff that we've worked with Yushin and Sherwood, but the idea of using not just break lines and spots and all of that stuff, but also using some of our topo modification tools to do slope-based grading, where you can have a geometry in 3D space that then it automatically grades away from that, and you can change the parameters of like how far away from that geometry before it starts to slope down, and then the sculpt tool, which lets you kind of do more like relative operations, where if you had like a slope and you wanted to like push a swale into that slope by make it 2 feet deep, but in relation to the existing, you can do that as well. And also smoothing the topography, so like building with break lines to like do big gestures, and then drawing a boundary and then like smoothing that whole area, and kind of just being able to make big bold gestures with break lines, but then like to smooth them out using those kind of more creative tools. Cool. So I'm gonna continue with carbon sequestration. Oh, and I need to share. I thought I was sharing. All right, you guys are real troopers. So carbon sequestration, how do we check where we're at, right? How do we know what we're doing? And carbon, there's a few things I just want to establish. We're sequestering carbon from the atmosphere, right? When we talk about carbon cost or embedded carbon for like manufacturing something like concrete or getting it to the site, that embodied carbon is embodied not in the material itself, it's embodied in the atmosphere. So when we but generally we look at that as a negative thing. So that's carbon negative, like putting all that stuff into the atmosphere. And then carbon positive is pulling it out. So like a tree is more carbon positive. And we have this cost, of building a site always there's costs to every material, every, installation costs, driving trees, moving a tree onto a building with a crane. That's a huge carbon cost. So what can we do? We are very fortunate that we have a profession where we can actually do stuff on our site. We can pay attention to these things. So let's make it easier so that we can do that. And that's sort of part of what we're trying to do, is make these challenges of getting the right data and calculating these complex calculations and keeping track of everything is something we can do with tools. Now, there are a few tools existing that we want to definitely give a plug for. Pathfinder, which does by climate positive design, does a full accounting of your site and allows you to kind of once you basically have designed everything, input all of your benches and all of these things and how far things are going to take to get to your site, and soils, and I mean there's so many things to put in, and it doesn't make sense to do that sort of accounting as you go, right? It just doesn't make sense. Carbon Conscience is really an interesting tool by Chris Hardy at Sasaki, who is creating this online tool, and I've got a picture of it here, where you can draw shapes right on your site and in a map, and then pick which shapes are what, and then get an understanding of carbon just for the areas and the what you're embodying, but also maybe what you would begin to sequester, right? Based on whether it's vegetation and things like that. The problem with this is we're still not in a design software space. We're kind of in this, again, still outside of the design software and the kind of the work of doing design and pushing and pulling things and making decisions. I had a great conversation with Chris about his tools, and he shared some of the data that he's using on the back end of this with both ASLA and ourselves, which is going to be part of the package that we share and show you today. But climate positive, just going back to this climate positive design by Pamela Conrad and some others, they're looking at, again, when you start and you install all this stuff, you're going to be in a carbon negative situation where it's not, you're never going to be carbon positive installing the site, right? Because it just doesn't work that way. There may be exceptions, very special exceptions, but over time the plants are going to sequester carbon, right? And you're going to go up and up and up until you get green, right? Until you and there's probably another graph I could have used, but that's how climate positive design is using it. Like on the above zero is green, below zero is red. One more piece of data that we wanted to talk about, and some other work that's happening, is there's a lot of folks trying to gather data for trees and how much carbon they're sequestering. Phil Zawaris, who's in University of Nevada, Las Vegas, gathered some of the local trees in his area and looked at the iTree, the website for iTree, and got all of these numbers for these different, each year, how much these trees are going to sequester. And then there's a space here where he's interpolated some of these, and we'll talk about that a little bit more. But just this idea that you can there's also stormwater, which we're going to be working with Phil a little bit more on, how his rationale for gathering this data and for CO2, but also stormwater, and how trees can also contribute to this whole water equation as well. So in terms of carbon sequestration, and plants, we have a few things that will sequester. So we've got the vegetated land cover. So there's some really great data from Sasaki in their database about this, and then the iTree data. And then we're also using ERA, in this case as well, to sort of be able to get the different attributes of the plants. So things like the color, this looks very familiar from the biodiversity thing that Ben did. This is at a much bigger scale. So these are all tree sized things. And even these trees are very large. These are the oaks on the site, the lobata. And we're doing some clustering and stuff. But basically you can see that we're calculating a carbon positive curve here, and we're going to show you that workflow here real quick. So if we open our workflow here, so I've got like a list of plants and how many I'm using. That's part of Plant Kit. We have like a schedule of plants. You saw that before. So we have this site that has like, say, for example, a lawn area and another lawn area over here. And based on the data that we have our sort of dashboard. It's showing us that lawn overall, based on installation, but then on over time, how much it costs to actually maintain the lawn. This is actually a negative value, but it's relatively low compared to some other things. So asphalt and concrete, concrete is at minus 62,000 kilograms of carbon over 60 years. And that's partly because we're also, we have to reinstall it every 20 to 30 years, right? The asphalt and the concrete are getting reinstalled. And so we're accounting for that as well. But the neat thing is if I say, okay, well, what if for some reason I can take that and I can actually move that to a meadow condition. So I right click on meadow and I say change object layer. There's a slight shift in the curves. And then obviously my, grass condition goes away and we're kind of now climate positive on the meadow. I'm just going to go back just to keep everything where it was. So that's the big idea, right? And then we have the different trees, and there's some parameters, just like the plant biodiversity workflow, where you can change densities and clustering, the radius cluster, and kind of the threshold of what is a cluster. Like where the size cutoff is on the plants. And then, so this is just an example. Like you could start to customize this and have it, have slightly different behaviors. And like the other ones, you can save settings and things like that. Let's just take one step back and look at the data that's going into this. So the first thing, okay, there's actually a tab, okay, here in our workflow. So you can bring in all of the area CO2 data, the plant CO2, and then the plant attributes, which is that ERA database, which we already looked at. So for the area CO2, this is where we are pulling from the material baseline from Sasaki. And so we've added a few of our own tabs, but let's look at their database first. So they have some great references, all of these data points. There's codes for them. And what we get are low, median, and high carbon factors for each one, and then a density for that material. And these factors are based on some of these other multipliers that they're using up here. And we're still understanding how all this works, but we want to continue to familiarize ourselves with the nuances of this so that the tools can kind of absorb some of the complexities of this a little bit. And the other thing we've done, so this is all of the like materials, and that's the bulk of this database, right? Is all of these materials and how much they have. But then you get down here, you do have some products. So if there's like products you want to look at this and try to start to calculate that stuff as well, great. And then they have these nursery kind of values that talk about the amount of carbon that can be sequestered here. So this is the, sorry, yes. So then we have our materials menu, which takes those densities of materials and factors, and it multiplies them to get these numbers. So if you say, okay, I want this certain soil or sand, and I there's a range here. There's quite a range, and I think we all need to get more familiar with how do we determine what that range is. But if designers are just trying to say like, okay, I just want to get a sense, comparing concrete to sand versus, lawn versus meadow, let's just start using the median, right? And you can take that and say, okay, it's 21. And then you could build a value out here for sand, right? And say, okay, sand, I'm going to put another line in and put this into, this is the CSV that you have to create for our tool. And part of the reason for that is that this is going to be so specific for every given project that you still have to sort of set some of these things up. And we eventually want to set up a kind of like a base database for sort of just general calculation, but we think it's important for people to kind of, it is important for people to build their own and to understand things enough. So the way this works is year 0, these represent the years. In year 0, this concrete is going to be minus 420 per cubic meter, per cubic meter. And in year 1, it's going to be 0. It will then interpolate between those zeros all the way to another 0. It could be, here or wherever. I don't know why I have so many, to be honest. I think I'll probably remove some of these. And we go to year 30, where we have to replace that concrete, and we have another spike, right? And then we have to add another 0. So this is essentially our acceleration or deceleration curve, depending. And it's like there's a spike, and then it comes back, and then we contribute more. But overall, the total of that, if I look at it's sort of a line that goes and it goes down a little. And then it's, so that's the total amount that it's contributed. So the sheet represents an acceleration or deceleration of carbon going up, carbon going down. And in this case, we're going, it's negative. So we're embodying that carbon every time we have to install, right, that stuff on our site and replace it. Then the lawn, for example, it also costs something. It might be more than this. These are kind of quick estimates. Then you have to remove more every time you mow every year. And so this number, there's no 0 after it. So this graph will go down but kind of come back up a little bit, but stay below 0, and it will stay that way through the whole time. But when you use that acceleration, it starts to kind of actually go down, right? Because you start down and then you go down, 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 because you have a certain amount still coming out every year. And then for a meadow, for example, you start at a low position, but then year 0, it's not sequestering anything, but by year 4, maybe that meadow has gotten established and it's up at a higher capacity for actually going climate positive. So there's like kind of a bit of a curve here, and then a more linear relationship moving forward, right? And then and there's probably, I'm sure like an ecologist or a climate scientist would be like, well, it's not quite right, but we're just, our main thing is to like give designers a really much stronger sense, and students a much stronger sense of when you add these things and move these things, what is the big change? Like if we went to this plant data and say, oh, plant density is 0.1, how does that change my overall equation? Well, it's not as good if I take this and right click and put this on the concrete layer. we're never getting climate positive. We're in a negative situation here. And that's an established wetland, so shame on you for taking that out. Yeah. Ben, am I missing any other details? Oh, I guess I didn't look at the tree data. Let's look at the tree data. Sorry about that. So the tree data allows you to. So this is our tree data, and we've taken some of those interpolated values out. So we go from 10 to 15, and as I was saying with the other one, it actually, these become keyframes within that acceleration or deceleration curve for carbon. And so we don't actually need to fill in everything. And that's another cool thing for you as a designer trying to kind of do a little bit of research and think through this thing. You're not having to put in every single year. Like, what is the value every single year for this tree? Or what is the value every single year for this this meadow, or whatever the case may be? You can just, we can take data like this where it's like, it's every 5 years in this area, because we just don't have, somebody said, oh well, I guess it's about this much after 30 years. Then we we're interpolating between those points. And then another thing about the data for the trees is that in order to match the the data from the trees, the carbon data for trees, those curves, and then the plant attributes, you just have to have the list of plants here. And you may need to go in, we're thinking through how we can make this a little easier for people to kind of pick plants and save plant selections. And I think I'm actually even getting some ideas during this workshop about how we're going to do that. So that's going to be a little easier, but right now it's mostly a demonstration project for how somebody can do this, and also an starter file for how a firm might begin to modify this existing Grasshopper definition to reflect their practice and their the goals that they're trying to meet with carbon and these other topics as well. So, any carbon questions?
Chris, yes, very interesting, all this stuff. I am interested in a little more info on, I think you said the carbon data for trees, mostly from the Phil Zauer's resource, or that's what I found to be a little less available than other items, basically.
So yeah, Phil's database is for local trees in the Las Vegas region. So that's only useful in that specific place. But Phil put that database together using iTree. And what we're hoping to do is get a better sense from him about how that database came together, so that we can help others create local databases of their own, or maybe if we can build that database ourselves. We're trying to be fairly transparent about this, that we don't have all of the data, but that there is some of that out there. And I think iTree is probably one of the best ones we keep hearing about. We're not as familiar with iTree, and every time I go in there, I'm completely confused. I have to admit, iTree is a very confusing place to go. But that is the one. That's the place I'm hearing is a good place to get the data. So
I'll have to look into it more too.
We want to have maybe we could start a working group or something. Because I think it's something we really want to solve, because we think plants are the thing that are, pulling carbon out of the atmosphere. And if we're going to actually be going climate positive, that's a huge thing for landscape architects to be able to utilize, for themselves as a profession, but also as global citizens and for the rest of the world.
I mean, I like to say, I think we're, I mean, obviously, in a sense, right, we're uniquely positioned to deal with this. And I think quantifying the performance of our projects in order to prove that is paramount, right? It's very important.
Yeah. Yeah.
But I also found, like you were saying, right, trees data, I think it's surprisingly, in a sense, a little less available. I'd love to sort of, yeah, we've talked about this, obviously.
Yeah.
But keeping that conversation going would be great, and work group sounds awesome.
Yeah, I think if I'm not mistaken, part of the way that's being calculated is iTree will tell you the DBH of the tree. It's a very specific trunk measurement that gives you an estimate of the tree's overall mass. And then Ben was the one who did a little bit more
I
research
poked around
on
with a little
ours.
more. Yeah, it's a little bit more specific to the actual trees that you're looking at and their growth patterns. So you insert like a species, and it has a little bit of information embedded about that, like its growth pattern. But then you also have to measure that tree and input that DBH as well, which is a very simple, that's a standard of measurement for calculating carbon content within trees, which maybe a lot of you are familiar with. But, we actually started building these calculators before we had even these two larger data sets that we were able to pull from. And it kind of became a, if you build it, they will come kind of situation. And that's the hope, is that as we're spurring on this conversation, making connections, making more extensive tree databases available will hopefully start to come, and we're actively pursuing them through people like Phil Sawaris and the tools that he's using, and others for kind of making the tree data as available as possible, since iTree does do it in some senses, but still requires a little bit of technical input to make that happen.
Yeah. So this brings up a big question, which, it's like, how do we automate some sort of process like that to like kind of really put out our feelers and kind of then pull all this information in and like then format everything and all that stuff. And so that's the next part of our talk, which is about AI. Oh, well, there's workflows. We'll talk about workflows a little bit more. AI. So the big question about AI is like, okay, is it going to take our jobs and all of those fun things? But I think, but before the machine apocalypse is upon us, I think there's a lot we can do with AI to. No, I'm being funny. So there's a lot we can do, right? With AI now immediately, which is to begin to use it as a tool for combating climate change. So there's obvious applications with AI for designers, like creative stuff, like let's throw some design parameters at it and ask it to kind of design something in a certain way, generate some ideas, whatever. It can be abstract, it can be maybe more specific, where people are even using it for rendering. Great. I think we're seeing plenty of examples of that online. And if you're not, just open up LinkedIn and you'll see all of them at once. So AI language models are, maybe if folks haven't tried them, I would say try it, because it's not hard. There's not a big barrier to entry to get into using it. It's just like having a conversation with someone who knows everything, right? And it is actually very polite in many cases. So you can automate things, ask certain questions. There's a lot of functionality that's coming out that people are using it for. But I think the big thing is that we need to kind of adapt quickly to these things, because they are coming very fast. And I think we, as a profession, want to start just really looking at how we can apply it. So we think it's important for us to talk about it more and more. We're talking about it a lot at our firm. and we think it was important thing. We thought it was an important thing to talk about today. So the big thing is the prompt, and why is prompt different than search? Why are we using that as our definition? So the prompt is the question. You go, you ask the question, and it's all about how curious you are, and what if you were talking to an older person who knew a lot of stuff, in order to get that information out, you just got to ask a lot of questions. You got to ask. You're not going to get the answers unless you ask. And there's ways of asking that are automated as well, right? Using scripts and things to actually ask automate questions. But all of these, just a disclaimer, we're still in this phase where there's the fact checking, that these AI models aren't necessarily fact checking themselves, right? They're kind of, we've created this big smushy brain, and it's gonna spit stuff out, and sometimes it even does what's called a hallucination, right? Where a lawyer might be asking about a certain thing, and the AI gives it cases that don't exist. Okay, that's a really good example of a really bad thing that it could do, right? So I think it's really important to understand that we should be checking these things. But again, I think they can build out a lot more faster. And for designers who are big, we're generalists, right? We're trying to capture all of this information, these big gestures of information, and eventually refine it into something that we can construct. This is a great tool for us to think broadly. But how an AI, the AI basically is trained. These large language models are trained on like everything. And certain search functionality, certain search or more specific applications are focusing those AI models to answer questions like climate-chat.ai is a great kind of example one. But basically what's happening here is that it's providing a bunch of context for you, so that when you go and you ask a question, it's going to give you some answers related to your question, but within this question, this climate context of domain of knowledge. But you can actually add a lot of context, and this is why it's not search. This is why we're not doing searches. We're doing prompts. We're creating a whole set of context. So when we do search, we're used to putting in a sentence or just a couple words, or searches tend to be very short, right? We are, sort of what we input and how we ask. At least I do. I think we're all that's what we're all used to. But the cool thing about AI is, unlike search, is that when you add more stuff, you actually get better results. You can get better results when you provide more context to your questions. So you can provide a whole PDF of information and give it to it, and then say, what's the best way to deal with X, Y, and Z within this? And it will take all of the different things it knows, and the context of that PDF or that pages and pages of text that you've copied in, and it's gonna kind of process things within that context. And so if you wanted it to, for example, if you want to start looking for materials that are really good for sustainability, cost, permeability, durability, all the abilities, you can give it the context that these are all of the parameters I'm looking for. I'm actually working in Missouri, in this region. What are the best, the closest material supplies? What are their, so you could ask all these questions, all these hard things, the complex things that we have to start to add up, right? And get kind of a bunch of answers for these things, and then you can ask it to format it in the CSV file, right? You can say, okay, now that you've done all this, give all this text to me in this very specific format, and you can tell it exactly. So here's and then you can do the similar thing for plants, right? You can sort of really create that context for plants and then get sort of output. So one of my big things I'd like to start trying is and I think I'm going to have to set up an API key and to really crank out a bunch of data. But what I'd love to do is set up some sort of mechanism to start building a better plant database, right? Give it the ERA, give it some of these databases that exist, and just have it, start to test that out, see what kind of data we get, put it in front of ecologists, put it in front of horticulturalists, and see. And so I think those are some really huge upsides to AI and how it can really supercharge our workflows and help us fight fire with fire in some ways. This crazy AI thing is happening. This crazy climate change thing is happening. Let's point one at the other and try to neutralize. So let me open this up. Hold on. I know it's only sharing the one window. There we go. So this is a quick example that one of our team members ran. And it's sort of asking about certain, sustainable materials for pathways and landscapes. It's a big general question. So we're going to get a bunch of just kind of big general answers, and then we can start to focus in and say, okay, give us more information about this thing, and then and we're not even getting close. I'm just sort of showing you like the beginnings. So, show me, a project located within 60 miles of Boston, right? So that starts to narrow things down again, and it talks through a bunch of options. And then this is also throwing a planting example at it. Okay, like what kind of things could we use? Give us species. Can you convert that species, convert it into a CSV file? And it gives you the format. And so this is just like a super fast search, right? Or prompt, sorry, super fast conversation you're having with this AI on that beginner's mix. So then you can get a little bit more detailed and start asking about certain kinds of typological conditions within your site, and start to answer some of the similar questions to PlantKit, and maybe you start to generate your plant list this way, and then rather than having that insane exploratory process of like trying to just generate a bunch of random plants, maybe you can go straight to hey, this is a list I really like, and then just focus more on visualizing it, seeing how it looks, and thinking more about the details and whether you're missing any plants, or whether you certain stuff maybe just doesn't fit into the conditions you're looking for. So there's different options here, and then we're just copying all that into a CSV file, and we end up with a little database. And there's a link to that in the PDF once we share that with you all. So it's pretty exciting. Like the creative possibilities are really exciting from both, a climate standpoint, but also just a creative standpoint with AI. And I think we're going to just be seeing more and more that we can do. This is using, I'm not sure if Lindsay used Midjourney, if they were using that, or DALL-E 2. Those are two of them. You can also now do image generation with Bing Chat. Bing Chat is now, it's GPT that can also see the internet, right? So you can ask it a question. So it's like search and large language model kind of together, which was one of the criticisms just a week and a half ago. This is all happening really fast, guys. So I think we'll find that it's more and more of a conversation with these things, and just trying to really ask the right questions and provide all the right context so that somebody can give us the answer we're looking for. I want to thank Ben for helping out with this workshop, and everyone else here who's come on a Saturday. Thank you so much. And also acknowledge Chris Hardy and the huge contribution he's making at Sasaki, and he's also doing an LAF fellowship right now. He's about to come out with his new carbon conscience app. He said he's reworked the user experience of all of that, which sounds really exciting. And the data that we were looking at and that we're sharing in the package is from that. That's credit to Sasaki. And then the folks at ENLP, who have been incredibly helpful with helping us understand how this water stuff works with CN numbers and TR55 and volumes of water. And Phil Zawaris, who I've mentioned fairly recently here. And then the rest of the Landau team, Lindsay, Gina, and Jake, who helped with this huge effort for this workshop. This was like a lot of work. So we hope everybody gets something out of it with these workflows. Like we said, 3 of the workflows are free. So you can, for 3 of the topics, and we're going to be coming out with a lot more. Let me just go back here. We're going to be coming out with a lot more workflows as we go. And workflows are great because they help people who don't know Grasshopper, and then they help folks who are trying to help people who don't know Grasshopper, right? So if you're an IT manager who understands Grasshopper and how to code something for somebody, you can adapt these tools for your team. And let me go here. Our campus website, our website has some new updates as of releasing version 1.2 of LandKit. We've provided a slight update to that. There's a LandKit 1.2.1 file within the participant package that has a few optimizations and fixes that we made. We also have this nice resource now for folks who are coming from different angles. You have people who are just designers who maybe don't know Grasshopper, just trying to solve problems, educators and students, people who are really good at coding and are like, what the heck can I do with this thing? And then folks who are managing larger projects. And then we've got office hours every Friday. Ben is there on the call, available for free. We also can do one-on-one time. You can just go and pay for an hour, and then we'll do like a tutorial consultation. We also do team training and project consultation. We use these tools on real projects, on some really big projects, and we would love to work with your team if you need like that extra help. And we've got this whole area. We've got our components reference page that shows how the components under the hood work a little bit more. We're going to be continuing to expand this, but we have all of the different sub tool sets as part of LandKit. And if you click on each one of these, they have a little thing that talks about inputs, outputs. We're going to be adding more information as to what do these things represent, what are the kind of inputs mean, or what do the outputs mean, how to use them. Yeah, and like I said, workflows. So we're going to have free and pro workflows for we already have, these are already available, paving workflows, and then the topo workflows are coming very soon. And we're going to be putting up the water workflows that we shared today. So there's actually 3 technically, because carbon is kind of under the water workflow right now. And then we have 1 plant workflow, and we're hoping to build out probably the most, like the piece de resistance is like going to be the pro plant workflow. It's going to be pretty intense, I think. And then if you have a bug, you can report bugs. You can go to the McNeil forum. There's a lot of support right now for these tools, and we're just trying to supercharge the work that you guys are doing, and we think it's so important, and we just want to keep amplifying what's possible in this profession.